All right, let's get right into it. Today, we're going to build the digital backbone for a real-deal web application. We're taking Python, one of the most popular languages on the planet, and hooking it up to Postgres, which is just a seriously powerful and professional database. By the time we're done here, you'll know exactly how to give your app a permanent memory so it can store, retrieve, and work with live data. Okay, let's do this. So you've probably run into this, right? You write a cool Python script, it runs, it does its thing, and then poof, it forgets everything. The second that script stops, all your variables, all your data, it just vanishes into thin air. Well, the key to building a real application, one that can remember users or save posts or track inventory, is persistence. Your app needs a memory, and that is the exact problem we are going to solve today.
But before we can even think about a database, we've got to make our first big decision. How are we going to structure this thing? In the Python world, it's kind of like a fork in the road, and it usually comes down to two major players, Flask and Django. This choice is a biggie because it really sets the stage for everything that comes after. Okay, so what we have here are two totally different philosophies. On the right, you've got Django. Think of it like a Swiss Army knife. It's the batteries included deal, a powerhouse that comes with everything you could possibly need, including a built-in tool that often hides the raw SQL from you. Then on the left, you have Flask. It's more like a simple, elegant toolbox. It's minimalist. It gives you the total freedom and, the responsibility to pick your own tools. For what we're doing today, which is getting our hands dirty and really learning how to talk to a database, Flask is perfect because it puts you right in the driver's seat.
So we're going with Flask. Awesome. Now comes the most critical part of this whole operation, making our Python code actually shake hands with our PostgreSQL database. We need to get them talking to establish that line of communication so they can start working together.
And believe it or not, this whole handshake thing, it happens in three pretty simple steps. First, we need a translator. See, Python doesn't speak PostgreSQL right out of the box, so we use a library called psycho2 to do the translating. Second, we use that translator to actually make the connection. And third, we create something called a cursor. The best way to think about a cursor is that it's our remote control. It's what we're going to use to send our commands to the database and see what it sends back.
And here is exactly what that looks like in actual code. It's not that scary, right? First line, we import our translator, psychopg2. Then we make the connection. We just tell it the database name, the user, and boom. That last line, con.cursor, that's us grabbing our remote control. We are now officially connected and ready to give some commands.
All right, the connection is live. And just like that, our humble little Python script has a brand new superpower. It can now speak SQL. And that is a huge deal. This isn't just about passively storing data. This is about actively commanding the database to do our bidding, create structures, add new information, find it later, and change it whenever we want.
No matter how complicated an app seems, a big e-commerce site, a social network, whatever, pretty much every single thing it does with data boils down to just these four operations. They go by the acronym CRUD, and you're going to hear it all the time. You either create new data, read existing data, update it, or delete it. If you can master these four, you've pretty much mastered the fundamentals.
So let's kick things off with the C for create. Before we can just start throwing user data around, we need to build the box to hold it. In database terms, that's called a table. You can just think of it like a spreadsheet with clearly defined columns. We need a column for the user's ID, one for their username, and one for their email. And see that serial primary key part? That's super important. It's like telling the database, hey, every time a new user signs up, just give them the next number in line, automatically. It guarantees every single user gets a unique ID, no fuss. Okay, our user table is built. Now let's actually put someone in it. We use our cursor, our remote control, to execute an insert command. But look very closely at those % symbols. That is not a typo. It is the single most important part of this code. We never, ever put user data directly into that query string. Instead, we use these placeholders, and we pass the actual data, Alice and her email, as a separate argument. Why? Because this is what stops hackers. This is how we prevent a really nasty attack called SQL injection. Seriously, always do it this way.
So you've executed your insert command, but there's a catch, and it's a big one. Nothing you've done is actually permanent yet. It's all sitting in a temporary holding area, what's called a transaction. The database is basically waiting for you to say, yep, I'm absolutely sure, make these changes permanent. And to do that, you have to commit the transaction. That's why I love this quote. Con.commit is literally the save button for your database. If you forget to hit it, all your work just disappears.
Okay, deep breaths. This is the wow moment. This is where it all comes together. We've got our Flask framework, we know how to connect to the database, we know how to speak SQL. Now, let's combine all of that and build a live API endpoint, a real URL on the internet that can serve up data directly from our database.
And this is the code that makes the magic happen. See that first line, @app.route? That's just Flask saying, hey, whenever anyone on the web goes to the /users page, I want you to run this function right here. And what does the function do? Well, it connects to the DB, it creates a cursor, just like we learned, then it runs a simple SQL query, select everything from the users table. It fetches all the results, and then, this is the key, it uses JSONify to package all that data up into a clean, universal format and sends it back out. That's it. That's a working API.
And this is what a browser or mobile app gets back. See? It's not a web page with colors and buttons and logos. It's just the data. Pure, clean, structured data. And that's the whole beauty of an API. Our server's only job is to be the single source of truth. Now, a fancy website can grab this data and display it however it wants. A mobile app can grab this data. Anything can use it. This idea, separating your data from your presentation, is the absolute foundation of all modern web development.
Okay, so you've seen how to write raw SQL inside of Python. You get it. It works. But now, let me show you the popular shortcut. What if you could talk to your database using just normal, clean Python code without ever writing a single line of SQL yourself? Well, that's the promise of something called an object relational mapper, or ORM. And this right here, this is the big aha moment. Just look at the difference. On the left is the raw SQL approach we've been using. It's explicit, you're in total control. On the right, though, that's the ORM way. User.query.all. That's it. It's just clean, beautiful, Pythonic code. The ORM, in this case a popular one called SQLAlchemy, does all the heavy lifting of figuring out the right SQL, running it for you, and giving you back a nice list of user objects. It's a whole different, cleaner way to work.
So you might be wondering, is it just about writing less code? And yeah, that's part of it for sure. But the real superpower of an ORM comes into play when your app starts to grow and change. Imagine you decide all your users now need a last_name field. With raw SQL, that's a pain. You have to go manually alter the database table, then hunt down every single insert and select statement in your code to update them. An ORM can manage these changes, they're called migrations, almost automatically, keeping your code and your database perfectly in sync. For any real project, trust me, this is an absolute game changer. Woo! We have covered a ton of ground. We went from a simple script that forgets everything to a live data API, talking frameworks, raw SQL, and these fancy ORMs. So let's just zoom out for a second and put all these pieces together into a complete professional web stack that you can use as a blueprint for your own stuff.
And here it is, your professional, scalable stack checklist. You've got Flask as your web framework. You've got PostgreSQL as your powerful, reliable database. You need CyclePython 2 to act as that essential translator between them. Then, optionally, you can layer on SQLAlchemy as your ORM to make your life easier. You serve it all up as a REST API using JSON, and you wrap the whole project up in a virtual env to keep everything clean and isolated. That's the stack. It's what the pros use, and it's ready for you to build something awesome.
So there you have it. You've got the complete blueprint. You now know the secret to giving your Python applications a permanent memory and serving that data up to the world. You have the foundational tools to build anything you can imagine, from a personal blog to a complex social network. The stack is here, the knowledge is yours, so the only question left is, what are you going to build?